Your brain's immune cells just went full couch potato. Seriously, scientists have caught microglia, the tiny immune guardians of your brain, sitting around stuffed with fat droplets and basically refusing to do their jobs. And while that sounds like a nightmare scenario for brain health, the good news is this discovery gives us a clear path to wake them up, get them moving again, and potentially slow down diseases like Alzheimer's before they spiral out of control. Microglia are usually anything but lazy. They're like the hall monitors of the brain, constantly roaming around, cleaning up debris, and snacking on the dangerous stuff like amyloid beta, the sticky protein that forms Alzheimer's plaques. When they're working properly, they're lean, efficient, and relentless, like little metabolic marathon runners. But in Alzheimer's brains, researchers have discovered these once active cells start hoarding fat. Instead of burning free fatty acids for fuel, they convert them into storage fat, pack themselves with lipid droplets, and gradually turn into puffy little blobs that barely move. When microglia get this fat paralysis, their cleaning efficiency drops by almost 40%. Imagine hiring a cleaning crew that shows up, eats all the donuts, and then takes a nap. That's what's happening near amyloid plaques. The debris piles up, the inflammation worsens, and the whole brain neighborhood starts to fall apart. For decades, we thought the problem was just the plaques themselves, but this new research from Purdue University shows that microglial metabolism is a huge part of the picture. The most exciting part is that this paralysis isn't permanent. The researchers traced the problem all the way to one enzyme, DGAT2, which acts like the fat factory inside microglia. Normally, DGAT2 helps cells make fat when they need to store energy, but in Alzheimer's, it doesn't get cleared out properly and just keeps going, cranking out fat until the microglia are overloaded. When scientists either blocked DGAT2's function or helped the cells break it down faster, the results were dramatic. Microglia shed the fat, woke up, and started gobbling up plaques again. It was like watching a couch potato suddenly leap up, lace on running shoes, and start doing laps. This is incredibly good news for Alzheimer's research because it means we might not have to attack plaques directly to see an improvement. Instead, we can reboot the brain's natural cleaning crew and let them handle it. That's a much more elegant solution, one that works with the brain rather than against it. And it offers hope that we could intervene earlier in the disease process before memory loss and cognitive decline become severe. It's also not hard to see how this might extend beyond Alzheimer's. Fat-laden microglia have been observed in aging brains and other neurodegenerative conditions, which means this discovery could open the door to treatments that protect the brain more broadly. If we can keep microglia in fat-burning, plaque-clearing mode for longer, we might be able to delay or even prevent multiple forms of dementia. And on some level, this research makes Alzheimer's feel a little less mysterious and terrifying. It's not just an unstoppable buildup of toxic gunk. It's a situation where your brain's immune cells are still present, still capable of working, but just stuck in a metabolic rut. If science can give them the nudge they need, they can start fighting for you again. So yes, your brain's immune cells may have gone full couch potato, but they're not beyond saving. The next generation of treatments might be less about scrubbing plaques with billion-dollar drugs and more about putting microglia on a cellular fitness plan, waking them up, burning off the fat, and getting them back to work. If we can pull that off, it could mean a future where our brains stay cleaner, clearer, and sharper for many more years. And that's a reason to feel a lot more optimistic about what getting older might look like.